In previous video, we were learning about the coroutines. So some introduction, we have seen something related to the coroutines and exception handling we have learned. So continuing with the coroutines, we have said that coroutines, it is a subprogram which will be having multiple entries and controls them itself. In case of subroutines or a normal procedure, what happens? It will be having a single entry and exit point. But in case of coroutines, we will be having multiple entries as well as it can switch between the different coroutines. So also when it returns back to the routine, what happens? It resumes the operation. Again, if the same coroutine is being invoked, then from where it is stopped, it resumes its action. So coroutine call is named as a resume. Coroutines repeatedly resume each other, and coroutines, they will be providing concurrent execution of the program units. So we also have seen that we make use of this transfer in order to switch between one coroutine to the another. So each time when the transfer is given means it will be passing the name of the coroutine to which the control need to be given. So here we can consider a screensaver program which is implemented using this coroutines. So here we are having two coroutines, that is US and CFS, where US indicates the update screen and CFS, it indicates the check file system. So these are the two coroutines, and first inside each coroutine it will be first initializing the initialization operations will be performed, and then it does the detach operations, and then transfer will be done. Okay, so for performing any transfer operation, it will be first it performs detach, and then only it will be performing the transfer operation. So transfer operation, within bracket you will be telling the name of the coroutine to which the control needs to be given. So in this transfer routine, some set of procedures will be implemented so that that control can be transferred to the coroutine that is given as an argument. So the syntax that is given in this program, it follows the similar programming language, and when first created a coroutine, it performs any necessary initialization operations, and then it detaches itself from the main program. So initialization will be done, and then it detaches the operation from the main program. These two operations will be performed when a coroutine is being first created. Then detach operation, it creates what does the detach operation does? It creates a coroutine object to which the control can later be transferred, and returns a reference to this coroutine to the caller. So detach operation, it detaches itself from the main program, then it creates an object to which the control can be transferred, and it returns a reference to the coroutine to the caller. So it will be giving the reference of the coroutine to the caller, so that later the same coroutine can be invoked again. Then the transfer operation, it saves the current program counter in the current coroutine object and resumes the coroutine specified as a parameter. For transfer operation, it performs the call function. Okay, so in this case what it does, it will be saving the current program counter in the current coroutine object, and it resumes the coroutine specified as a parameter. So in this example program, transfer of US means it will be pointing to a PC value. It will be having some PC value that will be saved within this coroutine object, and then the transfer will be given to this US update screen. Then main body of the program plays the role of an initial default coroutine. So main program will be treated as a default coroutine. Then we have seen earlier itself that coroutines, it will be executing concurrently. So it can be used to implement iterators and threads. Since they are executing concurrently, the coroutines will not be able to share a single stack. So in order to implement the stack operations, we make use of some concept like cactus stack. So using the coroutines, you will not be able to share a single stack because concurrent routine calls will be there. So in order to implement the sharing, we make use of a system called as cactus stack, in which each branch of the stack contains the frames of separate coroutine. So this is the cactus stack. This can be it represents the cactus shape. So that's why it is called as the cactus stack. So in this case, we are having a program structure as if A is having a procedure or a routine is having a P, then M is having B and S, in which B will be having D function, Q is having C and R. So this is the structure of a program. So if M, the arrangement is like M, it calls subroutine Q and it creates the coroutine B and A. So coroutine will be created in the form of a branch. Branch indicates the coroutines. Then here Q calls the function R, creating the coroutine C. B calls the function S, creating the coroutine D. A calls function P. So calling functions will be in the vertical arrangement, will be forming the vertical arrangement. So the dynamic links also, you will be having the dynamic link of Q in M. Based on the calling of the program, you can fix the dynamic link. And these arrows, it shows the static link. Okay, these arrows, it shows the static link. How static link can be fixed? Based on the structure of the program. That is P, it is placed in A. So the static link of P will be placed in A. So from this cactus stack, this much information you will be able to obtain. Then, so dynamic chain of a given coroutine ends in the block in which the coroutine began the execution. Then the static chain of the coroutine extends down into the remainder of the cactus through any of the surrounding blocks. That is, it depends upon the parent. Returning from the main block of a coroutine will generally terminate the program as a whole. When a given coroutine is no longer needed, the modular 2 programmer can simply reuse its stack space. And in similar, the space will be reclaimed via garbage collection. So once the routine finishes its execution, the space can be left as free. In modular, this can be reused, and in similar, what it does, it will be placed on the, it will be given to garbage so that it can be reused based on the garbage collection. Then transfer. To transfer one coroutine to another, the runtime system must change the program counter, stack and the contents of the processor register. So from the program, we have learned that you need to initialize the parameters and then perform the transfer operation. So before performing the transfer operation, you need to detach from its calling program. So transfer is like, before transferring from one coroutine to the other, the runtime system, it will be changing the value of the program counter, the stack and the contents of the processor register. That is, it will be saving the values that is currently used in the routine. When subroutine is being called, when a procedure is being called also, the same thing we will be using, isn't it? Inside the subroutine, which all registers are being used, those routines will be saved. Return address also will be saved. Similarly, in coroutines also, in order to perform this transfer operation, PC value and the contents of the processor registers will be saved. These changes are encapsulated in the transfer operation, where one coroutine it calls the transfer and then the different one it returns. Because the change happens inside the transfer, changing the PC from one coroutine to another simply amounts to remembering the right return address. So it helps in remembering it need to remember the return address by saving the PC value. Then related to switching of coroutines using this transfer function. To change the, we have seen we will be saving the values that is currently used by the coroutine. So we push the return address and all the other callee save registers onto the current stack. So what all are the operations that is being performed? Push all the registers other than SP, including the return address. Then current coroutine will be pointing to the SP. Current coroutine will be equal to R1. That is, R1 will be a parameter that is passed in the transfer function. So here in the program, we have given transfer of US. So US will be treated as a R1. So R1 will be given as a parameter, and current coroutine will be pointing to the R1. So the stack pointer will be the address of the R1. It is equal to R1. Pop all the registers other than the SP, that is including the return address, and return from the program. Okay, so push all the registers are saved. Stack pointer, current coroutine, and that return address also will be saved. Stack pointer will be updated to the argument that is passed in the transfer function. Pop all the registers after performing the operation. Pop all the registers other than SP, including return address, and return from the coroutine using this transfer function. Then so we have implementation of coroutines is like, one is for iterators. So iterators means we make use of a for loop statement. So here we can see an example in which for I in from to by of, this is one syntax. So if this for loop statement, compiler translates it's like allocating a space using new, from to by, first, last, step. These are the parameters that is given. Then this is I, then done. So it checks whether it is complete or not, whether the condition is satisfied or not. While not done, transfer of IT. Then currently pointing to the routine, current routine, that is IT. When it is not done, do transfer of IT, which means again the next iteration will be done, that is pointing to this IT. When once it is done, that is it has completed its execution, it has reached to that limit. If that is the case, means destroy of IT. So this much are the things that will be done using the coroutines. So it's coroutines, it helps in implementing the threads as well as the iterators. So process creation and passing of messages, all those things can be implemented using threads, and using this threads means it will be making use of the coroutines in order to implement the system calls that is performed by the operating system. So these things you will be learning in the lab sessions. I think OS and networking lab you will be learning. Okay, thank you.